Okay, well, welcome to Data Plus, our virtual 2020 Plus Program Expo. This is Data Plus Room 3, and we have a session right now with the Linking Urban Land Use to Aquatic Metabolism Regimes team. And that is Alexandra Bussey, Theo Kai, and Lindsay Hu. We're really proud of the work everybody's done this summer under really exceptional circumstances, and we hope you enjoy hearing about their work. So please go right ahead.
Awesome. Okay, so like Ariel said, we are Team 21, linking urban land use to river metabolism. And then my teammates are Lindsay and Theo. And then our client, we're working with the Duke River Center and Jim Heffernan. So basically, overall, our work aims to assist ecologists in their studies of river health and metabolic patterns and how they change in response to surrounding land use. So the kind of primary measurement we used was GPP, which is gross primary production, and it indicates chemical energy and biological respiration in a river. So this is actually really important because GPP corresponds to river ecosystem health and water quality. So when we study these changes, we can learn a lot about the ecosystem. So kind of the first part of our project was to compile a comprehensive data set that includes metabolism and land use data and on as many rivers as possible. So you can see here, these were the sites that we ended up filtering to that kind of had the most complete data. So we kind of filtered it to have watersheds, which are the main areas of water catchment for different rivers, to be less than 250 square kilometers. And they experience more than 88 millimeters of rainfall annually, and they're east of the Mississippi River. And then you can also see these sites in our ternary plot, as well as their composition of urban, natural, and agricultural land use. So we kind of filtered the sites and we looked at the different axes to kind of isolate the direct effects of either urban or agricultural land use.
All right, so next is assigning existing metabolic archetypes to rivers in our data set. So in a 2019 research paper, Dr. Phil Savoy and a few others took 47 rivers and tried to categorize them based on their metabolic behavior over the course of a year. The categories that they identified are what we are referring to when we say archetype. So very broadly, we assign these archetypes by comparing the metabolic time series. So how GPP changes at a certain river over the course of a year to the metabolic time series of the archetypes, and then choosing the closest fit. So you can see that here, us comparing Coosa River's metabolic regime to the two archetypes, Summer Peak and Spring Peak. So after we assign the archetypes, we then turn to look at how to best isolate these metabolic changes in relation to changing land use. So we did this by creating land use gradients, one urban, one agricultural. The urban land use gradient only included a subset of sites with majority natural or urban land use, but little to no agricultural. And the agricultural land use gradient only included sites with a majority natural or agricultural land use, but little to no urban. So we did this in order to isolate the effects of a particular land use on river metabolism, or GPP.
So now looking at the third part of the poster, with the archetypes assigned and the subsets of gradients created, we proceeded to visualize our data in two ways. First, with these box plots that you see here, and they tell us that GPP distribution changes and notably peaks at a particular range of land use cover, as indicated by the x-axis. Here we see that the peak occurs in the second quartile of the urban gradient, as indicated by the red circle, and the third quartile of the agricultural gradient. And then we generated ridgeline plots at the bottom to track how GPP shifts over the period of a year, where each colored band represents the average time series within a range of land use cover percentage. And these plots further confirm our observation in the box plot that the metabolic regimes of rivers spike in the second quartile for urban land cover and the third quartile for agricultural land cover. And our results seem to indicate that different land uses cause different metabolic responses from river, and that these responses are nonlinear. And one hypothesis that we can draw in light of these findings is that factors that stimulate GPP or metabolism in rivers have the strongest effect in the intermediate ranges of land use, so second or third quartile, whereas factors that inhibit GPP have the strongest effect in the higher ranges of land use, hence explaining the fall in GPP with increasing land use, whether it's urban or agricultural. And so with that, we sum up our presentation. We gathered and organized metabolism data for rivers and teased out their relationship with surrounding land use factors, which we hope will be able to help researchers in this field in the future. And we find that different types of land use impact GPP, which is the indicator of a river's metabolism or health, differently. So further research on land use factors that influence GPP, such as water clarity or like the nutrient levels in the river, could really help inform the urban and agricultural land planning when people are trying to plan development around rivers and be more mindful of how their planning can impact the river ecosystems. And that is our presentation. Thank you.
Great, so we can open it up to questions now. Feel free to either speak up or put a question in the chat box if you want to. And, well, if not, I mean, I would want to ask, what would be the next steps for this project if you had had a little more time?
I can keep on with that since I was kind of alluding to it and just now. So one thing that we really wanted to do, but because it was like too big, we kind of like, let's not dive into that yet because it's also very technical, is to just look at many different really specific factors that within each type of land use that can impact metabolism. So like for urban, we kind of started looking at population density, road density, or like the perviousness of the surfaces inside these developments, to see how that, like, each variable would impact GPP individually, and to see kind of like the relationship between these specific variables and GPP in order to understand how, the relation, like the specific variables to land use to GPP, kind of to like tease out that relationship. But it's a really complicated process because there's so many variables involved. But
yeah,
that should be the next step.
We have a question about GPP exactly. Can you explain a bit about what that is? That's from Donald Petco.
I can explain a little bit. Sorry if it wasn't super clear, but GPP is basically the microscopic organisms that live in a river, kind of like metabolize different nutrients, and it's really, really sensitive to change. So even a little bit of change can really impact the production. So it's basically the production of like carbon by these like microscopic organisms in a river. And it can tell a lot about the river health, especially variations in GPP, since it doesn't really vary that much, especially vary from its normal annual time scale. So that's kind of what we looked at it for the kind of respiration or aerobic respiration or production of carbon by these microscopic organisms.
Another question from Miranda. Were you surprised by anything that you found in the data?
I think one thing that we did not, like, wasn't necessarily surprised that we didn't necessarily expect was, we kind of expected that, there would be a more linear trend for things. Like we would kind of expect, maybe with more urbanization, GPP would go down because, it seems intuitive that urbanization will kind of, negatively impact ecosystem. But that's not exactly what we saw. So I think that when we explained our results to our client, he was like very excited to find, this kind of results that have, I mean, he explained that has a lot of academic value and is something that they can look into. So that's
Yeah,
to
because if
that.
there's a potential to make developments that do not have a negative impact, and that's been shown, that's, yeah,
Yeah, that would be pretty
right.
cool.
Yeah. Do people have other questions?
I do have one. Thank you so much for that again. Can you expand on why you think there is this nonlinear relationship? What could cause that?
Right.
Yeah. Oh, you can go, Theo.
Well, so we kind of teased at that with our hypothesis for future research, but one of the things we were kind of thinking about for like how to explain this nonlinear relationship is kind of looking at, okay, so like, you know, for some reason in the intermediate period of land use development, like, you know, 25 to 75%, for example, like GPP like is very stimulated for some reason, whereas it really tapers off at the very high ends. So we're kind of thinking of maybe in kind of intermediately developed areas, there's more stimulatory effects that are occurring, and they're really strong at first. So one thing we were thinking about was nutrient loading. So if there's development nearby, maybe there's runoff from nutrients that get into the river that the little organisms really like, and then they take it up and they produce a lot. So that could, you know, explain the spike in GPP. But with nutrient loadings, kind of like it's not necessarily, that relationship is not necessarily linear, in that it's like these organisms don't produce linearly. So it's not like the more nutrients you put in, the more they'll produce. We were kind of thinking maybe after a certain point, the organisms kind of like have enough and they can't really produce anymore, given all the nutrients that's being loaded into the river. So that might explain why with higher, very high urban or agricultural development, kind of like the organisms are not producing that much anymore, like they've had enough. So that's like one reason why, maybe, but definitely that's a future road for research.
Thanks,
Yeah, also
that's interesting.
one more and also one more thing to add. I think it's important to note that we don't actually know for sure that higher GPP necessarily indicates better river health. So there's a lot more to be like research on that, especially like specific regarding what exactly this fluctuation in GPP tells us about how the river's health is fluctuating with increasing a certain type of land. So we don't actually know that yet. We just know that, you know, GPP is increasing, but we don't, like, at certain ranges, but we don't know what exactly that means. So that's also something to be considered.
Thanks.
I'm just curious because I know a lot of students come to Data Plus and they don't necessarily have like coding experience or anything like that, and they kind of have to get really deep into something or learn skills that they didn't have before. So were there tools that you did not have any familiarity with when you started the program that now you've had to use a lot and you know, got some experience with over the summer?
I mean, ours definitely very, very, I don't know anything. I only know like a semester was worth of Python and that was it. But so like to learn a new language is, I mean, Stack Overflow a lot and you kind of just pick it up out of necessity. But it was like pretty interesting to like pick up a new skill. I don't know about you guys. How about you?
Yeah, I knew a bit of R before, but I think one new thing that I learned how to do was like making functions in R. I didn't really know how to do that before, but I've made a few.
That's great.
I mean, it's also like about, I think one thing I picked up is, you know, using like those repos and like GitHub and really knowing how to document your code in the way that will transfer to other people. Because like I've made errors so many times and it's just caused a lot of inconvenience because I didn't document something properly. So I think that's also one thing that I learned regarding like communication in terms of like academically in teamwork situation.
Alex, how about you?
Yeah, like Lindsay, I didn't know R before starting this, so it definitely was a bit of a learning curve. But yeah, I think one of the most interesting things that our team did was the smoothing and assigning of archetypes. I think that was the most like code intensive part of the project. Theo worked a lot on that, but kind of doing different clustering methods, really incorporating some statistics into it. I think that was very interesting, something never experienced before.
Yeah, I think like something that I wish that we could learn was definitely like the GIS aspect, because I thought that we might get to do a lot with like mapping and stuff, but I mean that ended up to be a pretty small part of it, and I mean I hope that we could have done more, but I'm also like what we got is already a lot for me. So
Yeah. I mean, has this affected your all's like career path or trajectory or field of study going forward at all?
that might be a bit far stretched, but it's definitely a very interesting experience.
Mm-hmm.
I think I'd like to do this in the future. I don't know, at least a little bit more. I'm a senior now, so I kind of have to be thinking about that, but this was fun. I really liked it.
Yeah, I mean, it definitely wasn't as much like face-to-face interaction. Obviously, that's not like the data science's fault. But it definitely taught me that I don't necessarily enjoy coding all day. I know
That's
that
fair.
most
That's
jobs
totally
after
fair.
college are looking at a computer all day, which is understandable, but maybe not be my preferred career path.
Yeah.
That's just as valuable as, realizing you want to get heavily into statistics and stare at screens all day. It's good to know that before you really commit yourself to a path. So, yeah, that's good too. Yeah. Do we have any other questions from the audience? Anyone? All right. Well, we can let you guys off the hook. Thanks so much. You did great work this summer, and I really appreciate you doing all this, especially with time zone issues and all of that. Like, it was a really extra challenging summer. We've tried to make it a challenging summer so you're not bored, but this was definitely a higher level than we had ever done before. So thank you for being a part of it.
Yeah,
Yeah,
and
it's really
thank
impressive
you
what you've
all.
done.
Oh, thanks.
Thank
So
you.
much positive energy. But thank
Yeah.
you all for organizing it as well. Must
Oh,
be
you
very
bet.
difficult.
It was interesting, but we learned a lot of new things too. I mean, we might start doing more hybrid work from now on. We'll see how it goes. Yeah.
Mm-hmm.
Yeah. So thanks again, and have a great rest of what little summer is left. Thank you. All right.
Thank
Yeah.
you.
Thank you.
Mhm.
Bye.
All right. Stop sharing.